Hey Nicole, this video is for your eyes only. I'm going to make it a private one and send you a secret password in your email. So remember that you're the only one that can see this, and if you want me to take it down, just let me know. Okay, so this is what I did. I'm going to run a factorial ANOVA on your DES questions. Looks like you got 28 of them. So what factor analysis does is it will take these questions, or they're called items in a factor analysis, and any one that's being answered similarly will be put under what I call an umbrella term. So if you had 5 different questions all measuring anxiety, and somebody was really suffering from bad anxiety, then all 5 of those questions should be answered the same. And that's what the computer does. It looks for that pattern and kind of lumps them together. But I'm just going to show you how to do this real quick. We're going to go to Analyze, Dimension Reduction, Factor. And again, we're only going to stick in the DES questions. If I can find them. There they are. So 1 through 28, not the total. And let me do some of my magic here. We're going to extract them. Now, we're going to come back to this. You say you only have 2 different things you're measuring with these 28 questions, but I'm going to see what the computer says first, okay? So again, we'll come back to this. And we normally do a varimax. That's an orthogonal rotation, if that means anything to you. We're going to save it as a new variable. And options, yeah, we're going to sort. We only want those items that load up relatively strongly with 0.4. And again, let's take a look at the output. Okay, so here's your descriptives for each one of these. Not really important here. Correlation table, not really important. This is important. This first one is the determinant does not equal 0, so that means we can continue with the factor analysis. This one says KMO. This number is kind of low, which means that your sample size probably isn't big enough. But again, we'll just keep running as it is. And the Bartlett's test of sphericity, that is significant. That means you should continue again. That means at least 2 of your items are correlated strongly enough. And this is your extraction box. This is what you want to look at. Any number here that's lower than 0.4, that means that item doesn't load up very well, but they all are very, very strong, so that's a good sign. And here we go by what we call the eigenvalues. So any eigenvalue greater than 1 is worth keeping. That's a rule of thumb here. But according to this your 28 questions are measuring 6 different things, not 2. But between the 6, you can explain about 86% of the variance in the way they're answered, which is very, very strong. Okay, so it looks pretty good except for the 6 part. All right, so real quick, let's see which items loaded up under your 6 new factors. And remember, this is the one we rotated, so this is the main one here. So your first factor, these deces seem to be similar, right? 22, 23, 28, blah, 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 blah. And for your second factor, these seem to be being answered similar, et cetera, et cetera. So when you have something that's double, like DES 25, it kind of loads up under factor 1 and factor 3. That's problematic. That means you got overlap, which you do not want. But the general rule of thumb, again, is whatever the bigger number is, the biggest positive number, that's the factor it should go on. Okay, so that's how we split this up here. But now we're going to go do it, and we could force it into just 2. Fixed factors, we're only going to ask for 2 instead of 6. And then everything else should be the same. And again, those are the means. Don't care about the correlation table. Again, your sample size is too small. And they all loaded up pretty well. Oh, there's a little one. 19 did not load up very well. You might want to think about throwing that question out. 10 did not load up very well. So we forced it to 2. And with the 2, you can explain about 65% of the variance in how they're being answered, which isn't bad. I mean, that's pretty good. So let's see who loads up under question 1. Would be 22, 23, 18, et cetera, et cetera, et cetera. Right? Bam. And question, or factor 2 would be 4, 12, 1, 11, blah, 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 blah. Bam, bam, bam. Now, we're going to do a quick reliability check on that Cronbach's alpha to see if these questions do play together well enough to be used in a correlation or something. All right, analyze. We're going to go to scale. Again, this is a Cronbach's alpha reliability scale. And so we're going to put those items that line up under number 1 together and check their Cronbach's alpha. Hold on, you don't need to see this. Got them all. Okay, so all of these items load up under the first new factor. Let's go ahead and check our magic here. We want the item scale. Scale if deleted. I think that's all we want here. So the magic number is Cronbach's alpha. So those questions do in fact line up. You can use that as a new variable, okay? Because this is much stronger than 0.7. So these questions right here, I'll send you a list to them. But the ones that load up under number 1 are fine. The Cronbach's alpha is fine, okay? So let's do the second one. And we're going to go to analyze again with the scale, reliability, and out with the old. In with the new. You don't see that. You don't need to see this. I'll pause it. Okay, those are all the items under factor 2. Everything else should be preset. Let's click OK. Again, we're going to check the Cronbach's alpha. And again, much higher than 0.7. So those factors, that factor should include those items beneath it. So it looks good to me. And I'm going to send you which items go under factor 1, which set of items goes under factor 2. Now I'm going to run the correlation. Let me rename those. Hold on. So whenever you run a factor analysis and you click that little save as a variable, that's exactly what it did. So I'm going to just call this variable A and the other one variable B. And remember, these are the results of your factor analysis. So now we just run a quick correlation between the two. Get in there, you, bam. And they're way down at the bottom here. There you are. Right, variable A, variable B. And we're just going to do a quick Pearson's on there. Click OK. And your correlation is... it's right there. 0. All right, I'm going to redo this real quickly. I'm going to delete these ones that have all the missing data. That's what the negative 99 is, right? Somebody marked it on the main sheet. So if it's got a negative 99, it's missing data. And these guys are completely missing, so we're just going to delete them. You don't get much of a change, I'll be honest with you. And I'm not expecting much of a change, but just let me delete all these guys, and I'm going to redo everything. Only take me a minute. Please hold. All right, no missing data. And again, I seriously doubt that anything's going to change, but what the heck, it don't cost nothing. And, okay, factor analysis, those are us. Everything's rotated. We're forcing it back into 2. Still get the same amount, 65%. And let me double check to see if any of these guys switch sides after the deletion. So we would go back to analyze, scale, reliability. So this was component 2. Let's see if we can't squeeze everybody on the same one here. So this one says 4. Oh, it doesn't have 2. Well, look at there. Okay, so I'm going to just delete them if they're not there. So this one says 4, but not 2. 12. 12 is there. 1 is there, 11 is there, 26 is there, 3 is there, 13 is there, 5 is there, 10 is there. Okay, so that wasn't such of a big deal, but let's see if it changes your Chromeback's alpha. It's still huge enough, so I would say get rid of question number 2. Let's go back and check for question number 1. And all right, who's on question 1? Who's on first? So 22. No, they all look the same to me. So since I ran a new factor analysis, it gave us 2 new variables, one of them without 2. So I don't think anything's going to change, but I'm just going to call this one, I don't know. Call this apple. Call the second one orange. Now we're going to go ahead and run a correlation. Correlation is sweeping the nation. Out with you, and we're going to do our apples and oranges. But again, I seriously doubt anything's going to change. And let's look up your correlation here. Nope, same thing. So there is no correlation between these 2 factors. Bad news. All right. I'll talk to you later. Bye.